Hi, everyone. Thanks for coming back again. This is Ken Shoulders number 42. And today we have two very, very special guests. Both have been on with us before, but now they're together. We have Pavel Osmera, and we're going to read through his paper on structured and magnetically treated water, which is absolutely amazing. I've read through it and highlighted it. And then we also have Moray King here coming back with us again today. And Moray's got a book that maybe Michael can and show to the screen on water as well. So it's really cool to have both you water guys here. So I'll let Michael go, but maybe you can show that book before we start reading here, Michael.
Yeah, it's funny because I've done a lot of work in water as well, and but yeah,
Yeah, me too. I
welcome.
actually designed a water filter a long time ago. Yeah.
Yep, great book. All right, I'll get started here, and please stop me at any time. Structured and magnetically treated water, properties, applications, and theoretical insights by Pavel Osmera, and his email and phone is listed right there. Abstract. Goal is to find the new and better models of electron and positrons as fractal torus structures. A new model of atoms and molecules will be presented. We assume that there are two types, type A and type B, of atoms that differ in the direction of rotation of individual rings. Type B, all rings rotate opposite to the directions of rotation type A, but both types have the same structure. The rotations of protons and neutrons in atoms behave similarly as cogwheel in a gearbox. For example, both oxygen atoms have the same structure, but the individual protons rotate in opposite directions in both atoms. This is necessary to make magnetic lines of force with opposite orientations. Magnetic lines are then created in the proton axis of both atoms. Only such oxygen atoms can create an oxygen molecule. Magnetic lines of the first oxygen atom and can thus enter the proton of the second oxygen atom. Every atom of oxygen has 8 protons, 8 electrons, and 8 neutrons. This principle applies to all atoms and molecules. This proposed model will affect the foundations of atomic theory, materials science, or cosmology. Keywords: fractal ring model, fractal substructures, both direction of rotation of proton, neutron, and electron, directions of magnetic lines, topological model of water, two types of atoms with the same structure, a topological model of molecule of water, revitalized water, diamagnetism of water, fractal electron structure, topological model of graphene. Introduction. Young people in schools learn that the nucleus of atoms consists of balls of protons and neutrons and electrons and orbit around such a nucleus. This model was inspired by the planetary system where all planets, including the Earth, orbit the sun. But this Bohr model cannot explain structures of molecules, for example, the hydrogen molecule, which consists of 2 hydrogen atoms. Bohr model can explain the hydrogen atom. This model was modified. This amount, and you can see the references. Electrons, protons are not balls, but rings with a fractal structure. But in the hydrogen atom, the electron is attracted by the electric force and repelled by the magnetic force. In the Bohr atom, the repulsive force is created by the centrifugal force. It is interesting that in both models of hydrogen atoms, the distances between the proton and the electron are the same in both models. The point model of electron or positron is now the most widely used model of the electron or positron. The magnetic moments of the electron, proton, and neutron are known. The measured properties can only exist if the elementary particles have a fractal structure with non-zero size. The fractal model of the electron consists of multiple negative substructures, and the fractal model of the positron consists of positive substructures. This explains the overall negative charge of the electrons and positive charge of the positrons. The measured properties of the electron cannot be properly explained by point models used in the theory of relativity and quantum mechanics. It now appears that the fractal model of the electron or positron can provide a basic explanation of the properties of the electron or positron, such as charge, mass, spin, magnetic moment, and the stability of the overall structure. Point models cannot well explain the physical principle for the exchange of energy between individual particles. Models of finite-sized objects can change size and shape in response to the presence of other objects. The fractal dimension of the electron was presented in the article, reference 20. This view contradicts the currently accepted view that the electron has no structure. This article is the first attempt to calculate the size of the fractal dimension of the electron, with the obtained size being 1.446. The vortex fractal ring theory could contribute to explaining what charge is, what structure the electron, proton, and neutron have, and their electromagnetic fields. Standard models of elementary particles imagine the electron as a quantum object with a possible wave-particle duality, with properties assigned to it to fit empirical data. Unfortunately, these properties are not related to any physical structure or to the motion of the electron itself. For many physicists, the electron remains a mysterious black box, for no one can figure out why the electron has certain line spectra, spin, mass, magnetic moment, wavelength, etc. The classical approach to particle physics is based on three ideas. The idea that elementary particles are physical objects with structure, and the idea that these physical objects are fundamentally electrical in nature. It's only two ideas. The discovery that the electron has magnetic properties further suggests to classical physicists that the electric charge carried by the electron must be in motion. The first rotating charge ring, SCR model for the electron, was proposed by A.L. Parsons in 1915. His model had a charge moving around the circumference of a thin torus ring. Previous spherical models, spheres, had only 1 degree of freedom in radius, r, while Parsons' rotating ring has 3 degrees of freedom, radius r, half thickness, small r, and rotation rate,
Omega,
what degree?
omega, the rotation.
Omega.
Thanks, Brendan.
This model provides more opportunities to fit the characteristics of the ring model to the measured parameters of the electron. However, Parsons' electron ring model and other recent SCR models have one common drawback. The total charge cannot be confined to a surface layer with zero volume because the compression of each segment of the charge repels all other segments with infinite force in accordance with Coulomb's law. This means that the electrons would have to explode. The charge cannot be confined to a point, line, plane, or plane with zero volume because the compression of each segment of charge repels all other segments in accordance with Coulomb's law. The electron is then elastic, having a finite size and ratio, mass, and energy. Yvonne Selin wrote in 1982 that a good theory of the structure of the electron is still lacking, and there is still no generally accepted explanation why electrons do not explode under the influence of the enormous Coulomb repulsive forces in an object of small size. A modern and original article on the electron is in reference 20. Section 2, electron structure, radius of electron, RCB.
There's a figure Figure one, forces between two subelectrons, E minus one, and plus E1 inside electron 0e. Okay, I'll let you continue with that. So we just look at the equations. We're not going to read out the equations.
That's an excellent drawing, Pavel. It's it's insightful to see how your mind works.
Yeah, definitely.
Okay, I'll start picking up. The following relationship result from figure one. Sine of alpha equals,
No,
and you can
we're
see
not
the
going to
rest
read
of
out
the
the
equation.
equations, Michael.
Yeah, yeah.
It's too sort of like
It's too long.
Yeah.
Yeah.
Yep.
just
Where force A sub zero equals force subscript is the acceleration force. And you can see all these other relationships between the forces. Is the, it says F sub B is the attractive Coulomb's force, and F sub mg is the repulsive magnetic force between the states and the electron, where E minus plus E minus 1 plus E plus 1 are the ring substructures of electron and positron.
Yeah, cool.
I'd like to stare at these equations for a while. These
equation two. Just
yeah, equation two. Pavel, do you want to explain any of these equations?
Yes, it is it can be related to this figure one.
Yeah.
Can I ask a question? Are you suggesting that in the substructure there's positive pieces? Is that the idea? Not just all negative, but there's some positive pieces?
Yeah, positive and negative. Yeah.
do I
think
go
so.
back to the diagram? Do you want me to go back to the diagram and and talk about that?
Yeah.
So is that the definition of the segmented charges? I never heard that term before, Pavel. Segmented charge. Is this a dipole that you're talking about? Different charges for segments of an overall field charge? Anybody jump in? I mean, I just heard
I think
heard
that's
it
what he's
read.
I think that's what he's trying to suggest, that there's, positive and negative, but there's also this positive, like not positive rotation, but rotation in one direction and rotation in the other direction with all of this stuff, right? Yeah.
Yes, but it specifically discusses, and Mike just read through it, segmented charge. And that's critical. So the definition is not given as to what a segmented charge is. I can understand it if we're breaking the charge field into toroidal elements that become dipole due to the magnetic and the electromagnetic influence in a motion system. But yeah, Michael just read through the segmented charge business.
Chip, why don't we carry on? Because there's a lot of illustrations in this stuff. The formulas aren't going to. Yeah, the formulas aren't going to really help anyone that's watching this, but that's why we don't really want to go through them in too much detail. But there is the pictures and that are going to explain things a lot more. And Pavel can jump in at any moment too.
Okay, Michael.
I mean, basically, what I'm saying, I mean, this just looks like a proper force balance done on different states of the electron. It's kind of solved the problem that's been brought up before. I mean, according to some of those other references, that the model of the electrons generally accepted would actually cause it to explode, like you rightfully wrote. So you're kind of showing how a balanced ring structure would be more appropriate, and that kind of gets back to all these things. It keeps coming back to this plasmoid structure, these EVOs, but in any case,
yeah, let's carry on, because this is there's like a lot of, there's 31.
The question I had to do was very fundamental, because if he has these subsegments, it's clearly these are components of the electron model. And the question is, if we have some positive subsegments, and negative subsegments, then you have the opportunity for stability. It's not going to explode apart because you have positive subsegments attracting in. And my question was, is that essentially what you were intending, Pavel?
My same question.
Yes, I think better is to continue. It is important. Is the radius of electron is the next page. This is not important. Very important is this radius RE.
Okay.
Next page.
Okay. Yeah. So let's just carry on with we'll skip, go through the formulas.
There is this next.
Next page. Shall I go to the next page?
Equation 8.
Yes. Yes.
Equation
Go
8.
to the next page.
What is the definition of N here? Capital N.
Wouldn't that be number of energy levels, isn't it?
Yeah. N equals 1 on the ground state.
Shell levels, or whatever, around orbital levels.
Yeah.
All right, that makes sense. Thanks, Brandon.
Okay, Mike.
Okay.
What do I do? Do I just read the writing and then just hit?
Yeah. Let's
the
just carry on. The pictures show a lot. Or was there a formula?
Return to equation 8.
8. Okay.
8.
Let's go.
8. This is a very important
Okay.
formula that we can use it in next calculation. That very easy to find, very easy right results. It will be next used. It will be used in next calculation. For example, the equation 9. They use this radius. This is inside.
It looks like mass times velocity, which is momentum, R sub B.
Circumference double loop. Quantum number. All right.
So do you want me to read, or does Michael want to?
Yeah,
continue?
I mean, if you want to take over, I mean, this is
Okay.
Yeah.
So
Yeah. Go ahead, Brandon.
2. So okay, for about equation 8, we then receive the size of electron radius RE. This formula is valid only for VE, which I assume is velocity. Velocity of electron much greater than 0, and velocity of light greater than velocity of electron.
Yeah.
2.2 quantum model of electron on a circumference of double loop with RE, radius of electron, see figure 23, is n of wavelength lambda. N is quantum number or orbital number, orbital level. So that's it shown in equation 9. So equation 10 there, where VEN, so velocity of electron at a certain orbital, a certain quantum number of orbital n, is velocity of electron if the electron has minimum energy VON on level n. For n equals 1 on the ground state, electron has maximal velocity there, that term there, has rotational energy ER, where alpha is the couple constant. So those two equation 13 and 14. For spectral lines of atomic hydrogen Lyman series, to have these equation 15, where TL is the term of Lyman series, spectral lines of atomic hydrogen. The total number of sub-electrons in the electron is M equals 2n times n over 2 equals 2 n2 equals 136 times 136 equals 18,496. In reference 24, page 15, is the equation for REN, which equals the equation 8. So there's equation 16.
Yep.
For quantum level n equals 1, we have equation 17. Energy E, is that M? Is that Rn or M? No, equation energy Em of rotation of the quanta of the electron on quantum level n. So that's the next one. That's this one at the top. So that's this equation 18. For quantum number n equals 1, we have equations 19 and 20. Energy En of levitation is in balance with energy Em of rotation. We can derive the distance dO as equation 21, and then we get equation 22. In our vortex fractal ring model, we receive the same size of the Bohr radius, RB, for that distance dO is approximately equal to blah, blah, blah. So you're saying, so Pavel, you're saying that for your vortex fractal ring model, you receive the same size as the Bohr radius. So your model predicted something that was already known in conventional physics independently.
Yes, it is related that it is possible because these structures are fractals, and these fractals is the reason why we receive the same result as Bohr radius.
What sort of mathematics? What sort of maths is this? Is this classical physics? Is it classical quantum? Is it quantum and classical mixed? Are you mixing conventional quantum with classical, or what's with your model?
No, not. I try to first one is a structure, and then on the structure I try to create a mathematical description. Not normally no mathematical description.
Is it similar to classical physics or quantum physics? Is there similarities, or is it very different?
In quantum physics, there are some probability. There is not important is a structure. For me, the structure is on the first place, and from this structure and through mathematical description, I try to make this calculation. I have opposite way from structure through mathematical description to the result.
Well, it looks like a little relativistic Einstein field equation in there with 8 pi epsilon. I mean, that's a good question Brendan had. I had the same question. All right, so let's go ahead.
Okay. We need to keep going, guys, because once you see the pictures and everything, it's going to come into play a lot better for you.
Yeah, we'll need to break it down in common sense terms.
Chip, do you want to
in
read?
A very high level topological definition.
Yeah.
So let me. I'm just trying to get oriented to it. So the gist of it is, we're modeling an electron itself, and now we leaped out and we made just a model of electron, and now we're explaining why the hydrogen atom exists with the Bohr radius, etc. Do we get the right picture of how we made a leap? We made a model of just the electron. We didn't even make a model of the proton.
Well, the model is the proton, electron, and neutrons, Moray.
I understand. We're going to make a model of them, unless you want to say my electron model is identical to the proton model. I don't think you're saying that. But we said without making a model of the proton, we took our model of the electron and predicted the Bohr radius of the hydrogen atom. Is that what has been said here? As a question? because I may not understand it. I don't think I don't understand it. That's why I'm asking the question.
I see
Anyway.
elements of momentum. I see momentum in this construct, mass times velocity. I see angular momentum, omega. I sense there's centripetal and centrifugal forces that are trying to balance. And
I see the word Bohr radius.
yes,
Bohr radius. So that means we made a little vortex fractal model of an electron itself. Sounds like a localized model, local particle. And then we're using that to predict the Bohr radius. Is that what's happening here?
or to attempt to match it, maybe.
Well, I don't think he meant.
It's a question. What's the intention here?
I don't think he meant to match it. It just that's the way that it came out once he went through all his
Yeah,
theory.
which
So
is the
again, why don't
beautiful
we,
part of it. Yeah.
again, guys, why don't we just carry on? I think this is 31 pages. So we need to keep moving along here.
You want me to read, or Ship? Do you want to read? What do you want to do? Shall I read?
I can read. I can read.
Okay, so,
All right, section 2.3, the spin of electron and positron. The electron has properties corresponding to its spin s. Oh, yes, I applaud that. The spin of an electron, I'm going to correct for grammar here. The spin of an electron is defined as angular momentum. Yes, it's omega. For spin on axis z, I have an equation which is looking at radius, velocity, and mass combined with the orbital definitions. Spin being equated to this entire construct. All right, where me is the mass of the electron, r sub e is the radius of the electron, and n is the number of substructures inside the structure of an electron. All right, so those are basic definitions. We carry down through there's 8 pi epsilon in mass and velocity. We continue down through a set of equations that are conflating spin with mass, velocity, and the basic Bohr construct, it would seem. And so we're trying to conflate, Pavel, jump in here. We're trying to conflate the orbital vortex momentum and velocity with something that has a toroidal topology, with something that is roughly equivalent to the old definition of the Bohr atom. And we're breaking it into ring momentums, radius, and velocities. All right, let's continue down.
H basically means quantum. H means it's quantum involved. Anyway.
Yes.
So,
Okay.
All right. So the result in equation 26 is coincident with the equation for the spin, where m sub s is spin quantum number. Playing cards have spin s sub z equals 2. All right, it could be either one. They have the same pictures on the top and the bottom. Absolutely. We get chirality. We get the same pair of cards if we turn the cards 180 degrees. Spin 1/2 can no longer be explained on a sphere or a ball. All right. It is necessary, emphasized in yellow, it is necessary to obtain the same structure by rotating it by 720 degrees. This can only be explained on the toroid ring. Yes.
Yeah.
Conclusion, therefore, particles that have spin 1/2 must be rings and not spheres. That is incredible insight, Pavel.
Yeah.
I really like it.
Yeah, exactly, right.
All right, 2.4, fractal dimension of an electron. Fractal dimension is a ratio providing a statistical index of complexity, comparing how detail in a pattern changes with the scale at which it is measured. Fractal dimension D is defined in equation in 23. This is labeled as 33. So that fractal dimension D is laid out with natural logarithmics of the orbital shell numbers, epsilon, I'm not sure what it is, and spin. Okay, where n is the number of substructures, Epsilon is, well, there it is. 1 over S is the scaling factor for S from n equals 136 in fractal dimension D. All right. The fractal dimension D is 1.446, corresponds to a crumpled line curve in 3 space.
Hmm.
Really? The fractal structure of an electron is very leaky. Yeah? It's called probability. So an electron can move at almost the speed of light, similar light to a photon. So it has certain degrees of freedom with this toroidal construct.
Yeah.
And
Now,
therefore defines the probability aspect of an electron cloud. It's it's Warner von Heisenberg all over again. You got no position if you know momentum, etc., back and forth. All right.
no, this is important. This is the important stuff, you guys.
There's a wonderful diagram, electron and a proton. Definition for R and alpha, the angle, the dimensionality, fractal dimensionality, D is unknown, but that really means it's variable. It's the way I interpret that. There's a Bohr model and a ring model. They're asymptotic at some point within the fractality scale. All right, so in answer to Moray's question, or in Brandon's question, we're not necessarily trashing classical physics with this new construct that Pavel has. They are consistent after some point within the fractal dimensionality framework. All right, I'm thinking out loud. Figure 2, levitating ring electron. In a hydrogen atom, we show the electron and we show the proton. F is the force between an electron and a proton at distance d. All right. The next set of figures shows, instead of electron clouds, contiguous toroidal interaction and overlap.
GS stands for globular structures, I think.
Yes.
Yeah.
And so this is maybe where the plasmoid concepts come into play, plasmoids being identical, tiny little toroidal structures. All right. And there's some definitions here. The last substructure in figure 3 is a helium nucleus, an alpha particle. The atomic nucleus is built from basic substructures. And there's a whole suite of definitions here. Two protons with parallel spin in the same direction can be joined on a common axis. 2 protons with parallel spin in the same direction can be joined on a common axis. This way we join basic substructures. So this is how we're fractalizing these toroidal substructures. All right, proton and neutron with parallel spins can be joined on a common axis also. Deuterium and tritium, as an example. 2 protons with different axes can be connected via neutron by magnetic forces.
Mm-hmm.
Why is the neutron in there? Very interesting.
Because he's basically building the structures of everything here, you guys. That's why I wanted to show all this to you. It's not just the electrons; it's everything, right?
Right, and it's taking a whole new view of the classical construct.
Well, you'll see in a second here when you talked about classical physics. It doesn't fall in line with classical physics. You're going to see some drawings here in a second that explain it a lot better.
And it's redefining the elements of classical physics and using them differently. All right, 1 or 2 neutrons can be inserted between 2 parallel protons. For instance, isotopes, etc. All right, in yellow, emphasize, it turns out that it's possible to combine these basic rules to create any real nucleus model of individual atoms of the periodic table of elements. Fractalized.
Also, what is the outcome? I'm just a quick question. What is the benefit of this model? What can this model enable us to do, say, practically or experimentally? So, what's the benefit? Why is this model better than the other models? And so, what can it can it explain free energy or anti-gravity and that kind of thing?
Well, sure it can. The levitating ring, the thing that we just looked at, explains that. But Pavel, go ahead.
Yes, it will be explained on next figure. We can create or atom of
I'm just trying
periodic table.
this figure here, yeah.
No, the one before that, Brendan. That one at the top.
There
See
you
how
go.
it says levitating ring?
Levitating ring, yeah.
So
Levitating ring electron.
So basically, you guys, he's showing how these structures, these globular structures, create all the elements of the periodic table. And if we just keep going, you guys will see what's
Okay.
going on here. So yeah,
Yeah,
you just need to carry on. I love the questions, but we just need to carry on. And
it's gonna be hard. It's gonna be hard for a podcast that we just don't get through it. All right. Nucleons in the nucleus are not arranged in the shells as in the case of electrons, but form spherical globular substructures with a maximum of 10 nucleons. Nuclear forces combine only a small number of neighboring nucleons. Spherical substructures of the nucleus, globular substructures, call them GS, are substructures of the nucleus. They are sequentially occupied by pairs of proton and neutrons with 2, 3, 4, and 5 pairs. The GS globular substructures are connected via two parallel. Next page. They're connected via two parallel protons into more complex units, shown in Figure 9. The globular substructures are the maximum, and a symmetry of occupation of nucleons is an extremely stable part of the nucleus. They're symmetric, and there is a maximum entropy associated with it. They create the atom with all of the occupying electrons completely occupied, electron levels in noble gases that are stable and inert. All right, the shape in emphasis, the shape of these globular substructures is created by repulsive electrical forces, green arrows of positively charged protons, red rings, and magnetic attraction forces, purple arrows, of the magnetic field of the protons and adjacent magnetic field of the neutrons. That's why we need ring structure. Damn magnetic field is stabilizing everything. Figure 6, neutrons have the opposite spin relative to the proton. And therefore, at the point of contact, have the same direction of the magnetic field, magnetic moments. Interesting. This magnetic field attracts and holds the two nucleons together, nuclear force, EVOs. These globule substructures are connected through proton-proton bonds, as in a bridge, to more complex entities. GS models can not only have the shape of a ball, but also a flattened ellipsoid, as in graphene, I'm assuming, carbon, and an elongated ellipsoid, or even more complex shapes. Some nuclei of elemental atoms may exist in more shape modifications. Allotropic structures. God almighty, the geometry is creating the final result, the resonant geometry. All right, the neighboring globular substructures with their magnetic fields interact with each other according to the number of their own nuclides, and their relative position, which is manifested by the deformation of the shape of the individual globular substructures towards the proton bond in the middle. Well, that's a mouthful, that paragraph. All right, we'll take a look at it in Figure 11 and 12. With these globular substructures, we can assemble the nucleus structure models of individual elements according to the number of protons and neutrons from the periodic table. Very good. Charge cannot be confined to a point, line, or plane of zero volume because compression of each segment, here we go with the charge segment, because compression of each segment of charge repels all other segments in accordance with Coulomb's law. The electron is elastic, finite in size, and finite in mass energy. Ivan Stella wrote in 1982 that a good theory of electron structure is still lacking. There is still no generally accepted explanation for why electrons do not explode under the tremendous Coulomb repulsion forces in an object of small size. Same issues that Feynman had with
Yeah,
EVOs
exactly.
right
Yeah.
from the very beginning. Like, how the hell does this work? Spin is a fundamental property in nature, like electrical charge or mass. Spin comes in multiples of 1/2 and can be plus or minus. Protons, electrons, and neutrons possess spin. Individual unpaired electrons, protons, and neutrons each possess a spin of 1/2, as in its base state.
Mm-hmm.
In the deuterium atom, 2 hydrogens with an unpaired electron, 1 unpaired proton, and 1 unpaired neutron, the total electronic spin equals 1/2, and the total net nuclear spin equals 1.
Yeah, it's mixing. What I get about it is mixing, like you were saying, Chip. It's redefining classical. It's mixing a bit of redefining classical with quantum. Because if it's got
Yes.
H bar, if it's got H or H bar, that means quantum. Anyway, there's that.
Yes, okay. In the next figures are shown ring torus structures of hydrogen deuterium atoms with a levitating electron. Okay. Amazing diagrams here, combining electron and proton, combining electron, neutron, and proton. Deuterium atom combining all three. Yeah.
Sorry.
So now the next page is where you're going to see how it's not the same as classical. This is Pavel's theory, which again, I believe you deserve the Nobel Prize for this.
Eddie, do you know what classical is? Classical physics is. It's
Well,
just
flip the next, Brendan, just flip the next page because the answer is just right there.
I must say some important
Let me speak a
thing.
minute. I'm saying classical. When you got velocity equals distance over time, that's classical. Quantum is
yes,
do with quantum. So you have to anyway.
Yeah, Pavel. Yeah.
We tell this structure, topological structure, because they are not in right sizes. Because if we use right sizes, we can show in this figure.
Yeah. Yeah.
It's only topological structure. The important is how this subparticle are connecting each other.
Yeah.
Interesting. So the size of the old definition in classical physics of an electron cloud doesn't matter. It's how they interact. And the size was related, as I recall from classical physics, to probability. Nobody knew where the hell the electron was. And now you are telling everybody where it should be by a whole different set of logic rules.
Well, the mechanism, I think he has that diagram of electron, and that's supposed to be a single electron. And now this electron is really large, let's say with the Bohr radius for that ring. So the electron is not a tiny little thing with a tiny little radius. It allows the ring to grow and be large. So that's your smeared electron cloud, but it's now a single electron that's allowed to be at the Bohr radius. So that's a huge entity as far as the size is concerned, and yet it's a single electron. So the idea that, oh, I have this flexible ring that, depending on where it is, that can be quite large. Now, do I have the right picture? So a single electron ends up being this large entity at the size of the Bohr radius, which is way huger than a tiny little
a lot of these alternative theories borrow bits of classical quantum and relativity. Even Paul's subquantum kinetics borrows some from special relativity and things like that. So they all overlap a bit, you know.
Yeah, well, that's fine. But my question is, what I just said, is that correct? I mean, I'm looking, we were calculating electron radius. all of a sudden we have a Bohr radius for but a single electron. And then you would say, oh yes, the radius is flexible. It can, depending on the situation, it doesn't have to be a tiny thing. It can be a big thing like the Bohr radius. Is that a correct, do I have the correct picture? That's my question. I mean, I'm thinking this, but I don't know if this is what Pavel wanted to convey. So that's why it's a question. So
Yes,
Pavel,
and I would
can you
add,
say that?
Yeah, and let's let him answer. Or will it be more apparent once we go to the next page?
well, let me add an addendum to Moray's question. I suspect the levitating electron is a stability point. And if it is not levitating, it has potentiated the vacuum. And if we can design at a molecular, down at this level, if we can design differentials, we can create zero-point energy. At a molecular level, if we can build potentials into this construct, this toroidal construct, where the proton, the electron, and the neutron interact in a fractalized system where the stability is self-emergent, if we can torque it per se, we create the potential fields, and we create the engine room for EVOs. Am I completely out of the ballpark on this? I need to see a big picture before we go down into the goddamn weeds with the details.
Again, you guys, let's just carry on because the drawings and the diagrams will be self-explanatory. And this is what I want to show you guys. So we have classical, and maybe I'll start reading. So we have classical on the left-hand side, and we have the new theory, which is part of Pavel's theory, but it's also Ken Shoulders. It's who else does this? I'm drawing blanks, but
Bob Grenier.
Yeah, exactly. Bob Grenier. So here we have the sphere, but Pavel is saying no, it's this ring structure. So we got classical against versus the new theory. In B, we have the structure of atomic nuclei. Again, this is Pavel's structures. You can see how they're completely different. They're using toroids. And the toroids are electrons, neutrons, and positrons in combinations. So there's the structure. Now, in the planetary system, you have, the electron going around the proton. In Pavel's system, we have a levitating system, which is completely different than classical physics again here, guys. So this part, I don't know if Pavel, do you want to explain a little bit about this part? Because this part is really, really very important to all of it.
Yeah, the levitation aspect, yeah.
What are your thoughts and insights on this, Pavel?
There's a bit of a language barrier because Pavel doesn't understand English very well.
Yeah, exactly. That's why we're, yeah.
But anyway.
Okay, so we'll carry on.
What's Pavel's native language?
Czechoslovakia?
Yeah.
What's his native language?
Czechoslovakian, I think. Correct me if I'm wrong.
Yeah.
Oh, really? Does he live there now?
Yeah.
Oh, cool. He can interact with Bob Grenier. He lives there.
Okay, so let's go to
no, go back, Brandon.
Yeah, go back to the number 4.
You're missing the super most important thing right here in D, right? So so now dark energy and dark matter, this does not fall into subquantum kinetics, essentially. We view this stuff as the ether, but this open system and closed system, so if it's open, you've got radiation and energy. And when it closes, this is where you've got your particle, when your particle forms. So the fractal ring vortex theory of 4 dimensions is self-organization, no? So basically it organizes itself, right? This is not classical physics. This is something completely different.
It borrows ideas from classical physics and uses the torus ring would have classical ideas and quantum or whatever mixed in with it. But it's not the same as classical physics. But a lot of these theories, they borrow ideas from classical quantum and relativity. They just
Yep.
redefine it in a different form.
So let's go to the next one, and this shows the periodic table of elements. Pavel, I would love to get if you've got all of this in an email, I would love to see this in an email, because this is amazing, you guys. He's basically taken the whole classical view and said this is not what it looks like. This is what it looks like according to my theories here, right? So this is the periodic table of elements.
I think the only thing I would add to that, Ed, that each one of these structures, each one of these elemental structures has a unique resonant frequency. And that is a combination of the toroidal substructures that are built into the thing.
Right.
Frequency is everything.
Yeah, I totally agree with that. Using these globules, GS, we can build more complex core structures of individual elements according to the number of protons and neutrons of the periodic table of elements. So now this drawing below here, this is really important, because here you have a diagram of the electric repulsive forces in green with those green arrows in the middle, and the attractive magnetic forces in purple, which you can see. And then we've got the magnetic field, the proton, the neutron, and the electric field. Very, very, very important model of everything here. We'll carry on because it will be more self-explanatory as we move along. The conjunction of globules through proton-proton bonds. So, I mean, look at this. Pavel, you've got a computer program that corresponds to all of this software, do you not?
This figure was done with my colleague because, and now I change it. I on 3D printer I make this ring structure and combine it together. There are next figures because for me it is easier to make this big structure on 3D printer.
Right, right. Yeah, exactly, because we're going to see pictures of these structures that Pavel has built on a 3D printer and then put them all together. And that's why I kind of wanted to keep you guys moving along here to see the actual brilliance of everything that he's done here, essentially. So here's the core nuclei of carbon, different carbon isotopes, C12, C13, and C14. The globules can bind to each other by magnetic bonding through proton-to-proton bonds. Between two protons in the proton-to-proton bond can be inserted 0 or 1 or 2 neutrons. See figure 10. And that's how the isotopes change, basically. The number of neutrons inserted differs between the individual isotope of the elements. On figure 10 are presented ring models of carbon isotopes with the isotopes of individual elements. The number of neutrons in the nucleus increases, and these are usually located between two protons, or they form the surface skin of protons of the outermost globules. As a result, the repulsive magnetic force to the electrons increases, and the isotope has a larger radius than the element in the base state. Nuclei composed of globules may not only have the shape of a sphere, but also of a flattened ellipsoid, carbon, or an elongated ellipsoid, many other cores, and even more complex shapes. Some nuclei of element atoms may exist in more shape modification and tropic structures. The neighboring globules with their magnetic fields interact with each other according to the number of their nuclides and their relative position, which is manifested by the deformation of the shape of the individual globules. As a result, the known bonding angles of carbon, nitrogen, and oxygen have an effect in the arrangement of the crystal lattice modules and shapes. Let me go to the next page. We've got his models of the deformation of carbon nuclei. Deformation of carbon nuclei globules is the first, figure 11. And then deformation of oxygen nuclei globules in figure 12. The nucleons in the atomic nuclei are not static. First, they have their own magnetic moment, and in each nucleon, rotates charge along the axis of its toroid. These rotations are bound to the adjacent nucleons, and form a sort of gearbox. Magnetic moments of opposing nucleons then show us where the energy of binding, show us whether the energy of binding with the electron enters the globule or comes out of the globule. So it either goes in or out. This also determines what magnetic moment must have an electron that binds to a pair of neutrons. Yeah. Rotation of oxygen nucleons and direction of magnetic moment at the carbon nucleus. So now this is where we're going to see all those models essentially. So here's a model, similar outer structure of carbon, silicone, I don't know, is that
Germanium.
Germanium.
Okay, and the tetravalent atoms. The proposed model was gradually modified to best match the known properties of nature. Wow, that's cool. So yeah, so basically we're looking at what nature has and making sure that it was all fractal. Fractal structures allow for significantly simpler subsequent construction and calculations of these ring models. Number one, a pair of atoms with the same structure. It was revealed that there must be two types, type A and type B of atoms, that differ in the direction of rotation of the individual rings. In type B, all rings rotate in the opposite direction to the rotation of type A. Both types A and B have the same structure. For example, a molecule of oxygen on figure 15. So this is really interesting. So it's totally symmetrical, but you have spin in one direction and spin in the other direction. Is that the case with all of the elements, Pavel?
Yes, yes. And this figure, it was done on 3D printer.
Yeah, exactly. Yeah. So the oxygen models, the red are the protons, right?
Yes, it is a topological structure that is not in a real scale, but
Okay.
very important are the arrow that
Oh yeah, yep. The arrows, yeah.
green and yellow.
Yep.
One from a proton go out and in second proton go in. That this is important. This is explain why this have this same structure but opposite rotation. It must this magnetic moment must be from one is go out in next atom go in.
Yeah.
That explain this oxygen molecule.
Yeah, this is just absolutely amazing. Yeah, so the yellow rings are the neutrons and the blue rings are the electrons. So the blue ones are all the charge clusters that Ken Shoulders talks about and Bob Greenyer talks about. And that's where we have done all our research. But what I'm trying to say and what we're bringing in here with Pavel is we bring that research back, but he's applied it to everything.
I think in carbon structure,
Mhm.
it is interesting because the structure is symmetrical that is not necessary use it, because if we make a rotation 180 degrees, we receive the same structure. In this carbon, we cannot recognize this principle, but it is the same.
Yep. Yeah, totally.
There's one exception. But all atoms must be joined by with these two types. It is impossible to connect the same structure. It is impossible. Must be type A and type B.
Yeah, so basically you have rotation in one direction, rotation in the other direction, and in my mind, when the two meet, there's something very special happens, and that's the element happens essentially. So you're saying that you need rotation in both directions, spin in both directions to make all of this function correctly, right?
Yes, important. Both have the same structure. They differ only in size of type of rotation.
Yep. Yep. So one basically cancels
Because
the other out.
both rotation have the same probability.
Right.
They must exist in nature with the same number of this type A and type B, because probability both rotation is, I think, the same.
Yep. And I think you're absolutely correct with all of this. This is absolutely amazing work. Like I said, yeah, we need to nominate you for the Nobel Prize.
Does this idea at all relate to antimatter? Because everything ended up being opposite in the underlying torus structure. So that's a question. Does it relate to antimatter?
I think, yeah. Pavel, what do you think of that? About that statement?
Yes, this is structure of water molecules.
Okay.
But this is the topological structure. It is not in real scale. It is try to show the connection electron, neutron, and protons each other. But if we use the right scale, that the center will be only dot. We cannot see this connection.
Right.
That's why we use this topological structure, that we can recognize the connection these rings each other.
Brendan, I think you missed a page.
I missed a page.
It should be on page 7.
Yeah.
Right? Okay.
We saw that one. Keep going down.
I think you jumped.
All right.
We
So I
saw
went
that
on to the
one.
next page. Is it? If this is the next page, is this right?
Nope, that's, yeah, it looks like page 7 is missing.
Page 7. Okay. Well, what do you want to do? Do you want to just read out from it, from your side?
Yeah, I can do that.
Take this down. We'll just take it down like that, and just let's just yeah, take it down and read page 7 or something.
Okay, so page 7, figure 11 is the deformation of carbon nuclei globules. And then in 12, there's the deformation of oxygen nuclei globules. The nucleons in the atomic nucleus are not static. First, they have their own magnetic moment, and in each nucleon rotates charge along the axis of its toroid. These rotations are bound to adjacent nucleons and form a sort of gearbox. Or maybe we did read this. Magnetic moments of opposing nucleons then show us whether the energy of the binding in the electrons enter the globule or come out of the globule. This also determines what magnetic moments must have an electron that binds to a pair of proton neutrons. Rotation of oxygen neutrons in direction of magnetic moment, the carbon nucleus. Okay, let's go to page 8 now.
Page 8.
I have a feeling I screwed that up. I think we read through some of that stuff. But like Pavel says, topology model of water structure. Now, this is really important because I mean, we are water essentially, and water is most everything in the universe. So this model is very important. Topology model, molecule of water. Rings were painted or printed on a 3D printer where the red rings are protons, the yellow are neutrons, and the blue are electrons. In the topology representation, the distances between the individual rings are not correctly scaled, which Pavel told us. Protons are red, neutrons are yellow, electrons are blue. In the center of the water molecule is an oxygen atom. With such a size of the oxygen atom, the lower portion of the hydrogens would have to be about 10 m apart.
10 meters apart.
Okay, 10 meters apart. I was going to ask, yeah. Since we are interested in the bonds between the oxygen atoms and the hydrogen atoms, bottom in figure 16, the topology representation is more convenient. If we had the water molecule shown on figure 16 in the correct scales, then the oxygen or the oxygen atom would be a dot. Simplified topology model of water type A. The red sphere is a simplified model of the atom of oxygen. The red rings are hydrogen protons and the blue rings are oxygen electrons. It's very, very cool that he's got actual three-dimensional models that he's built. And this is the part of the paper that really started to blow me away. These water molecules, type A water molecules, must combine with 3 type B water molecules so that the magnetic moments and field lines are directional. This hexagonal form from type A and type B water molecules allows for the formation of a 6-pointed snowflake, see figure 20. And again, it all explains stuff very most amazingly. Topology hexagonal model of water. 6 water molecules, 3 times type A, 3 times type B, so 3 times rotation one direction, 3 with rotation in the other direction. The black sphere is a simplified model of a water molecule, figure 16 and 17. So there's the black in there. Figure 19, cellular membrane, large clusters of water molecules and smaller hexagonal water structures. So again, you've got rapid cellular hydration, cell membrane, large water conglomerates, regular water, hexagonal water, vitalized water. Okay. And then we've got on page 9, figure 19 shows large clusters of water molecules that cannot pass through the membranes of living cells, plants, and animals. These large clusters of molecules can be broken into smaller hexagonal structures shown in figure 19 by a magnetic field. We receive so-called living water or vitalized water. The living water is in 31 on page 78, okay. Snowflakes, 6-pointed snowflakes with hexagonal centers. So again, he's explained how snowflakes are formed essentially and why they're formed that way. The large conglomerates structures of water can be changed by a magnetic field to hexagonal, changing the diamagnetism of water. Rotating swirling water creates a magnetic field that can change the structure of water. Because each moving charge, electron or proton, creates a magnetic field. For example, in a mountain stream, water flows around stones, which creates a magnetic field. In addition, the water is also oxygenated, or it's got oxygen added. A magnetically treated and oxygenated water This water has the same properties as water in a mountain stream. That's kind of interesting. Can be created using several manufactured tap accessories. I found this was fascinating, actually. For example, figure 21 and 22, and he's showing there's a price comparison between the Vortec spring power spring Swiss version and the Czech version. The looks like the Czech version is 708 euros and 620 Swiss francs for the other version. So he's basically showing us methods of creating structured water with using these tap attachments. Both designs, Swiss and Czech, have a chamber with with rotating water. The moving charges of the water molecules create a magnetic field that changes the connection of water molecules. Diamagnetism changes water. Diamagnetism changes. Water is then more repelled by magnetic field. At the same time, air is sucked in through the holes, which oxygenates the water. The goal is to get water into the kitchen with the quality of water from a mountain stream, which is most amazing. The Czech version adds a magnetic field of magnets to the magnetic field created by the rotation of water, which increases the diamagnetism, and the water is revitalized more quickly. The Czech version also has a where are we here? Revitalized water passing more easily through the membrane of the cells of living organisms. For example, cut flowers last twice as long in vitalized water, seeds germinate much faster, and their roots grow faster. Vitalized water loses its properties at a temperature of 90 degrees and becomes ordinary water. That is really interesting. So it needs to stay below a certain temperature. Therefore, it is not suitable to make tea or coffee from vitalized water. Even the tongue can distinguish vitalized water from ordinary water, provided that both waters are at the same temperature. The tongue is more sensitive to water. Vitalized water tastes different. Oxygen is lost from the water relatively quickly after 15 minutes. That's also very interesting. Magnetic properties, diamagnetism, gradually decrease over about a week. For example, a water cress that grows in about 4 days has only half the length of its roots, with the same green leafy part. MVV, magnetic vortex vitalizer. Thawed water. Thawed water has the ability to retain the crystalline structure of ice hexagonals, which is optimum for our organisms. So I've always liked cold ice water. It has the same properties as magnetically treated water. Applying fresh and thawed ice water is suitable for treating skin diseases. Now that part I did not know. Meltwater rejuvenates and makes the skin elastic. It retains its miraculous properties for a maximum of 8 hours. Fresh thawed water is the best quality. Yep. We can drink thawed ice water that is warm, maximum 37 degrees Celsius. Thawed ice water from natural snow and ice is not suitable due to the contamination with harmful substances. The properties of ice vary significantly depending on the temperature, pressure, and purity. Ice is water that is frozen into solid state, typically forming at temperatures of 0 Celsius. Virtually all ice on Earth has a hexagonal crystalline structure. That's interesting too. When water freezes, it increases its volume about 9% for fresh water. The effect of expansion the expansion during freezing could cause frost damage to building foundations and roads. It is also a common cause of flooding in houses when water pipes burst at the pressure of expanding water as it freezes. Because ice is less dense than liquid water, it floats, which prevents bodies of water from freezing from top uh, sorry, which prevents bodies of water from freezing from bottom up. The diamagnetism of melted ice has been measured. See figure 28. Its magnitude is the same as that of thawed magnetically treated water. Therefore, water from melting glaciers is very healthy, definitely. Water treated by electrolysis. By connecting currents to the electrodes, acidic water, dead water, begins to accumulate on the anode, and alkaline water, living water, to the cathode. That is really interesting. This type of water originated in Uzbekistan,
Uzbekistan.
yeah, in the oil industry around 1980. Water activated in this way could be used in construction, as it has shown a 30% higher strength in concrete. I love that. I'm going to be building a big, giant concrete building. I love that. We're going to try and do that. In one experiment, they watered a cotton bed with dead water and then with living water. To their great surprise, the cotton plant began to grow on this bed, catching up with the cotton plant on the bed watered only with living water in growth and suppressing it in the number of buds. Does somebody else want to read? I think I'm losing my Chip.
Yeah, I can do it.
Yeah.
Right, they accidentally bathed in a pool with alkaline living water. They noticed the healing effects of this water. It is stated in reference 29 what can be traded with living and dead water. The device uses rectified current using 4 diodes, Greatsbridge, with an alternating voltage of 230 volts. Between stainless steel electrodes, cellophane or parchment is used to separate live and dead water. I used baking paper and a safe adapter with a direct voltage of 48 volts. Recommended treatment, prostate, edema, angina, joint pain, headache, hemorrhoids, flu, cough, hepatitis, smelly feet, and heartburn. That covers it.
That's funny.
Mathematical description, number 5, section 5. Electron has a radius RE and spin S. ME is the mass of the electron. VE is the circumferential velocity of the electron ring, and lambda is the wavelength of Broglie's equation.
Yeah, this is amazing. I'm happy that Moray is here to see this also.
Yeah, this is the engine room here.
Yeah, exactly. This leads exactly back to what we were talking about in the last one that we had with Moray, right? This idea of the torus and it tightening upon itself to create these charge clusters. Yeah, sorry, carry on.
Almost looks like a Mobius loop. Interesting. All right, so the black spheres in figure 23 represent the motion of subelectron rings moving helically at the surface of the torus. Wow. There are N over 2 double loops, and every double loop has a 2n subelectrons fractal structure of the electron has N and N subelectrons. Okay.
Very cool. Now,
Set of equations.
Yeah, this one, I don't know if we'll get into that, but maybe, Pavel, what is this telling us at the end here, this equation?
Wade through
that
this.
sounds like magnetization.
Yeah, go back to the first top there, Ed, real quick. Yeah, the first equation in green there.
Yep.
You know, I see essentially mass times velocity in the electron radius is equated to momentum. A energy density in relativity was also considered in the same way, I believe. That's what Einstein envisioned.
And then he
said he equated momentum with the electron radius. And Pavel is also conflating, it would seem, angular momentum with the electron radius also.
Yeah, actually, I think if we keep going to the next, and it does sort of explain stuff again.
Yeah, let's go down
to the next page. Yep. This is really cool too. This is awesome, this part.
The spin S sub z of the electron and the magnetic momentum M sub z.
And that's what
All right.
that equation was looking at.
Yeah. All right.
Yep.
Subsection 6, methods and experiments used. A common method in physics is to describe a given phenomenon with equations. For example, the Dirac equation predicted the positron, which is the antiparticle of the electron. Another example is Niels Bohr, who preferred the principle of complementarity. For example, is light a wave or a particle, a photon? Bohr was fascinated by cubism, which sometimes allowed the coexistence of opposing views. Yeah, complementarity. Another interesting example is the pictures in the book written by Thorne. In this book, there's a picture of quantum hole.
Foam.
Quantum foam.
A picture of quantum foam, which is a fractal structure, loops and smaller loops on them,
Yeah.
fractalized loops. When describing a black hole, they had to go from a sphere to a ring toroid. In my opinion, the ring of a black hole is the largest ring, which has fractal substructures such as proton, neutron, and electron rings. The whole damn thing is fractalized, is what Pavel's saying.
Yeah.
Fascinating. These smaller rings are further composed of smaller rings, and so on to the structures of dark matter and energy. I use the opposite procedure. First, I try to imagine structures that could explain the given phenomena and then describe them mathematically. It is interesting that contemporary physics does not use fractal description.
Yeah, exactly.
And thus simplified fractal calculations. As an example in my explanation of the structure of light, how is it possible that light sometimes behaves as a particle or sometimes as a wave? Emphasized in yellow, in my opinion, it is a change in structure as shown in figure 24. Here, two vortex structures close to each other and in a structure and two vortexes close into each other and
Yep.
a structure is created,
Yep.
which is enclosed a certain amount of energy, a photon, or more of these pairs connect into an energy structure that has a wave envelope, behaves like a wave. So we have definitions.
This is amazing what he's got going on here.
Yeah, the twin vortex structures kissing pine cones, as Dan Winter would say, a
Yep.
wave envelope, vortex pairs. I'm trying to disseminate this quickly. There's one vortex pair, ray structure, radiation, light ring structure, particle. The whole thing is dependent on the frequency of the vortical spin, I suspect. Okay.
That's interesting. We might try and. That's
So
interesting for subquantum. You said the frequency of the vortical spin. You know the
Yeah,
rotation.
which is
yeah. I was just thinking.
which is the rate of time passage, right?
that's right. Yeah.
And this is why three-dimensional time creeps into the problem.
And
So
see this.
if electrons and protons and neutrons are spinning, their spin, that's where the frequency might come into play.
So this topology transformation is really ultra important. Could you please go back to that? This explains how as we were looking at before with classical physics and the new theories that he's got going on, how they actually work. So when you've got more vortex pairs in the wave envelope, you end up with vortex and the energy structure, and this is radiation or light. So it's open. When you've got one vortex pair, then you've got a ring structure, and this is when a particle or a photon is formed. So this right here explains how he goes from a closed system to an open system and from energy to a particle, essentially. Correct, Pavel?
Yes. Yes.
Yeah.
Because it is open structure.
Yep.
You are right.
And
Based on the
notice the pair I was going to add, like the Feynman diagrams where the photon propagates and then during the propagation it has electron positron pairs to come in and out of existence. You have the concept of that pairing symmetry
Yep.
to comprise a photon. So I'll add that to the insight.
Yeah, that's beautiful insight. Thank you, Moray. Absolutely. So if we go on, I guess, to the next one. You wanted to be a painter.
When I was still studying at university, I painted a picture with rings in two complementary colors, red and green. This picture was supposed to show the connection between good and evil.
That's cool. Wow.
Well, the yin and yang in the universe, the reciprocity and Turing wave, subquantum kinetics.
Yep.
Ed's been talking about the same thing. Rings with two complementary colors, blah, blah, blah. We have a complex diagram here with H1 and H2 hydrogen. That's deuterium and standard hydrogen, I guess, building into, it looks like it's hexagonal in its macro crystalline form. Rings structure of graphene. Oh, I see. Okay, 6H2 creates the structure H1. Side view of the ring model of graphene, which is 1 molecule thick. Okay.
You can see all the toruses there in that model. This is amazing stuff, Pavel.
All right, go on to the next page. Let's see what's there. All right, so figure 27 shows a topological model of graphene. Side view, blue rings are electrons, yellow neutrons, red are protons. And the structure of graphene in those two figures explains why graphene has higher conductivity than gold, silver, and copper. The upper blue electrons spin on parallel axes. Therefore, these electrons do not have much gyroscopic problem moving sideways under the influence of a lateral electrical field. So you can charge graphene, it becomes a dielectric, it becomes a conductor based on the flow of these apparently loosely bound electrons. All right, to measure the diamagnetism of water, we designed the device shown in figure 28.
Wow.
And
that's cool.
It looks like a piezo device, like a pressure device, but maybe we're just looking at the refractivity of light going through the water would be an indication of its structuring. All right, so using this very sensitive device, the diamagnetism values of individual water samples, such as untreated water, after a magnetic treatment of water, and melted ice, those three different versions, were measured. The diamagnetism value of melted ice in magnetically treated water is twice as large as that of untreated water from a kitchen tap.
That's interesting. I didn't know that. Wow.
Yeah, well, chlorine messes up, fluoride messes up a lot of shit. All right, so balance between electrical and figure 29, the balance between electrical and magnetic force in the ring hydrogen. Okay, this is the engine room. Okay, and the ring hydrogen is in balance. In the ring, hydrogen is balanced between the attractive electrical force F and the repulsive magnetic force F. And that's why the damn toroid is so important. It is imparting self-emergent stability.
Yeah.
And levitation, in Pavel's words.
Yep.
If it's not stable, it sure as hell ain't going to levitate. Okay, so big equation. We have elements, force, electron, distances. Pi is always in the mix. Some trigonometry, geometric algebra, the sine of 2 alpha on the end of it. All right, where I sub B is current inside the ring structure of the electron. I sub E.
Yeah, the current.
Inside the ring structure. So that's why pi gets involved. All right. In the Bohr model of the atom of hydrogen, in Bohr's model, the atom of hydrogen is a balance between electrical and acceleration forces. For the levitation model, there's a balance between electrical and magnetic forces.
And I think that's so critical right there, this point.
And electrical, you can consider acceleration to be gravity, right? So Bohr was maybe not defining it as such, but electrical and gravitational forces balance the Bohr model, where gravitation is the result of the omega, the vortical helicity spin associated with those kissing pine cones.
Yeah.
Electrical and magnetic. Okay. All right, go on.
And so this next page, Moray, this is exactly where you were starting to talk about matter and antimatter. So that's why I knew this was here, and that's why I kind of wanted us to just keep going with all of
Yes.
this, right?
Before we break from that last page, it's when they talked about levitation model, the diagram showed one ring being the proton and a bigger ring, the blue ring, being the electron. It showed them separated, like they were
Yep.
oriented in space far away from each other, as opposed to, let's say, symmetrically, where one ring is inside the other ring. So the blue one was
Right.
larger, and then that, and so the levitating was making, the diagram didn't match that. My imagination, I could say a big fat electron ring to be the smeared electron cloud, but it's an object that's that big for a single electron, which kind is the theme. How can we have something big being, and held together? And calling it levitation, I could see, it's larger and separated. And so as I look at the equations, we have R sub E, the electron radius, when we have the Bohr radius. And so we have a conflating two ideas. One, those two radii, and apparently a large smeared electron, a big levitated electron that's way expanded at the Bohr radius. What I'm trying to do is seeing, is this the right picture? In other words, I'm thinking these ideas as I see the diagram, but I'm not sure if that's what Pavel had in mind. So because I see an offset for when he calls levitation, and I would picture it symmetrically inside because the Bohr radius is symmetrical around the nucleus, and so I'm just struggling to clarify in my own mind, trying to lock onto these definitions because I guess to summarize, for an electron, we have a classical radius for the little point particle electron out in free space versus the Bohr radius for the smeared charged cloud electron. And so I have, so in order to map it to the equations, I have to know which of these radii are we using in during different sections of the presentation. Because you see my point? There's kind of a confusion. If I have the right idea, that's the part I'm not sure about. And this is what the model is that he's trying to communicate. Do you guys understand my question?
I do. I would add this to it. It would appear that the smear Bohr radius is the probability aspect that came in from Heisenberg and Schrodinger and everybody else who was studying quantum physics in the 1920s. What Pavel has done is, I believe, allowed a stability topology where the ring structures can move apart and start to levitate. And there's a self-emergent stability point that does not equate to probabilities.
Yeah.
And so if we could do away with probabilities with Pavel's model, that's a big deal.
I didn't say there were probabilities at all. I was just saying we're making a large ring structure for an electron that ends up being the structure of the electron for the Bohr radius at the Bohr scale, the Bohr radius scale, i.e. a large electron. It's a structured entity. And when he said levitating, it's the diagram, I think, when he had it offset to the left. Here's my electron ring, here's my proton ring, where I would have the proton in the middle one torus inside the middle of the large electron torus. And it could be that that's still what he had in mind. That,
Well, that's right. But the probability aspect in classical quantum mechanics, I believe, Moray, has to do with the size of that electron cloud. That is the definition of the probabilities.
yeah, and is he making a physical big electron cloud? That's what because he's created
Exactly.
structure, right?
I agree. Exactly.
I made a big electron. It happens to levitate. And the word levitate looks like it's offset, but if it was symmetrically located, like I said, yeah, it's a big one there. And it's symmetrical around the nuclei. And then it would start to make sense. But I'm injecting my thoughts. I don't know what the intention was on the model. I'm just struggling to piece it together.
Same thing. Pavel, was your intention to do away with the probabilistic nature of Bohr's model with, these subset elements of toroidal rings that have self-emergent stability at the levitation point? Does any of that make sense? If you are trying to do away with the probability aspect of this giant electron cloud that pissed off everybody in physics 100 years ago, then that is wonderful. And if you found a way to do it with the toroidal subfractalized elements, Bob Green,
Pavel doesn't understand English, right? So he's not.
I know we're a little stuck here, Ed.
I would suggest that's exactly what it is. Yeah.
All right.
Again, if we maybe carry on, it might help clarify everything, you guys, especially this part.
All right. So I'll continue here a little bit. I'll slow down a little bit. All right. So we have an origin with a dichotomy of matter versus antimatter. We see protons and antiprotons in the mix. We have fractalized substructures in the mix, anti-fractalized substructures, super black hole versus an anti-super black hole. Okay, yin and yang, origin of matter and antimatter. Stare at that for a minute. Oh, and time is involved.
This looks like, to me, it looks like the Turing wave moving back and forth between space-time and time-space.
Yes.
That's exactly what he's got drawn here, essentially. He's just using different words, but it's basically the same idea, right?
Yeah, and everything is in motion. We talked about that here a few weeks ago, Moray, right? Everything is in motion.
Yeah, and now contrast this with the AB type opposite spins thing we were saying earlier, and AB type, but I didn't get the impression on the AB stuff it was supposed to help with structure, that it was an antimatter thing. Other than the concept, if I got exact opposite spins of everything, then it has a flavor of an antimatter thing. But it didn't seem like the AB stuff was this matter antimatter. I pose the question to everybody: do you agree that AB stuff wasn't matter antimatter? It was something else.
It was negative spin. It was opposite spin.
Opposite spins, right? In many models of charge, that not standard models, but people that are suggesting helicity for charge to exist had the notion of opposite spin. And so that's why it's a little bit confusing, because we have that notion, but it seems to be applying to do two different things. So that's another point of confusion for me. And if you guys could clarify, I can't clarify it because this is all new to me.
I think that the spin and anti-spin thing is the 0 point, and that's where all the magic happens. That's just the best way that I can put it, right?
As a follow-up to Moray's question, could you extend that to transmutation? Could you conflate spin and anti-spin, A and B systems?
Well,
obviously with matter and antimatter, but could you also in the periodic chart create transmutation by combining different spin? Right now, if you ask Rock about it, they say, fuck no. Classical physics refuses to acknowledge any transmutation capabilities due to spin alone. It's all about charge. And I think that's absolutely wrong.
Yeah.
just to put my bias in it. Spin is, I think, responsible for absolutely everything. And Moray is asking the same question here in a sense. Anyway, origin of matter and antimatter. We have parallel universes. We have black holes shown in this diagram, protons, fractalized substructures, the Andromeda Milky Way galaxy, extending through a black hole, the oscillating universes. Everybody likes that. Open structures is dark energy, altered structures, dark matter.
Open structures,
All right,
dark
this,
matter, yeah. Okay.
yeah, this is a macro view of cosmology.
Mm-hmm.
Balanced origin of matter and antimatter.
Oh, was somebody going to read that?
Yeah, eventually galaxies such as
No,
the Andromeda Milky Way with the sun and earth can arise after a
Brendan,
certain amount.
Brendan, you need to go back.
We missed a little piece there, yeah.
Yeah.
It was
Oh,
highlighted piece
sorry
there.
about that.
Yeah.
Figure 30A shows the idea hypothesis of the creation of matter and antimatter from nothing, the beginning of everything, origin at zero time. And we know that this is actually the Turing wave moving back and forth, like I said, between space-time and time-space. A reverse process must also be possible when everything disappears by combining matter and antimatter, and we would reach time zero. In the area of matter, fractal substructures arise, from which, over time, the elementary particles of matter, protons, neutrons, and electrons, and from their atoms and molecules arise. After a long time, all matter is pulled into a super black hole. I wouldn't say a black hole, I'd call it a singularity, and I'll explain that maybe down the road. A similar process will take place in the realm of antimatter. Figure 30B shows the large black hole that can already emit fractal substructures from its center. Figure 30C shows the gradual creation of fractal substructures. Over time, the basic particles of atoms, protons, neutrons, and electrons are formed. The open arrangement of small substructures create dark energy with repulsive properties. The closed arrangement of small structures, substructures, will create closed structures with attractive effects, gravity. So he's talking about the open and the closed, like he did at the very beginning there when we were talking about the classical and his new theories. Eventually, galaxies such as Andromeda and the Milky Way with the sun and Earth can arise. After a certain time, the process may reverse the direction of transformation, then the black hole will absorb everything. That does not follow subquantum kinetics. Subquantum kinetics is an open system. It does not revert back to compression because there is no Big Bang essentially in subquantum kinetics. After a certain time, the process may reverse the direction of transformation, then the black hole may absorb everything. Then this process may reverse the direction of transformation again, and we get the oscillating parallel universe. Section 7, a section of my presentations and conferences. I found this to be really interesting. He's got a photocatalytic device for eliminating viruses, including COVID-19, bacteria, mold, odors, and cigarette smoke. The electrostatic filter uses a negative electrode, number 25, with graphene surfaces, patent registration image. Very cool. And then we get into a really big formula with the electrons. And then at the bottom, Ampere's law and Coulomb's law. And on the next page, this is the part that I like. You can go to the next one, Brandon. The vortex structures. And he's just showing some of the vortex structures here. Is that water? Yeah, that's water rotating like that. That's amazing. Look at that. And then again at the bottom, same thing, vortex structures. And then the conclusion. So this, you guys, might help a lot also to Moray to maybe put in perspective what he's got in mind with these models that he's built, and this whole idea of having protons, neutrons, and electrons as these toroidal structures in his conclusion
Is
here.
this near the end then?
This is the end. Yeah, there's just this page and another one. Does somebody want to read it?
Yeah, okay, I'll go ahead then. Okay,
go ahead.
conclusion. The point electron positron is still a dominant feature of the modern model of electron positron. But electron, proton, and neutron each have measured amounts of spin, angular momentum, and a magnetic moment. These features can only exist because the particles have structure and a fine non-zero size. The electron structure contains more negative substructures, and the positron contains more positive substructures. This explains the total negative charge of the electron and the total positive charge of the positron. Actual properties of electron cannot be explained by point-like models used in theories such as relativity theory, quantum mechanics, and the Dirac theory of the atom. Comparison shows that only a physical fractal model of electron-positron with finite size can explain the fundamental properties of electron-positron, i.e. mass, i.e. charge, mass, spin, magnetic moment, and stability.
That's a very important statement there.
Just as ordinary objects are composed of material substance with size and shape, so also by the principle of unity and the philosophy of structuralism, an electron must be composed of a material substance with size and specific shape. While points cannot provide a physical mechanism for the exchange of energy between particles, a finite size object will change size and shape in response to the presence of another object. The number of substructures of electron n must have even number divisible by 2. Must be an even number divisible by 2. In the article, reference 20, n was estimated at 42 and n equal 34 is derived in this article. The fractal dimension was given d equals 1.48 and now d equals 1.446 is recalculated. The derivation of the size of electron with torus structure, figure 1, can be done with geometry on figure 23. Inside the electron are positive positron substructures E+1 and negative substructures E-1. Negative substructures of electron E-1 are N2 over 2 equals 9,248. The positive positron substructure e to the plus 1 has N plus N2 over 2 equals 9,248 equals N. The electron has N minus, I can't read that, plus N plus equal those numbers there, equals N2 substructures. The positron and the electron have the same fractal dimension, D equals 1.446. The electron and positron have substructures of matter and antimatter. This explains where the antimatter is. Antimatter is contained in the substructures of basic particles, such as the electron, positron, proton, and neutron. All atoms exist in two types, type A and B. They have the same structure, but have opposite magnetic moments. Atoms of type A and type B can then combine to form molecules. This principle allows us to explain the formation of hexagonal structures in water, e.g. a snowflake. All models in this paper have topological structures. The fractal model of the proton, neutron, and electron allows us to explain what dark matter and energy could be. Small fractal substructures can be part of dark matter and energy. If they form closed structures, rings, they are matter. If they form open chains, they are energy.
Again, super important. So sorry, Brandon, but that is so important.
Unfortunately, these small fractal substructures cannot be observed with light. Dark matter, see figure 3D new, manifests itself, for example, in the equal rotation rate of the inner and outer parts of galaxies. Consideration for figure 3D to the right, new. Perhaps dark matter, which is 5 times more than ordinary matter, is related to gravity and inertial mass. Dark matter, which consists of tiny fractal substructures of observable matter that attract each other, could explain gravity. Dark matter, which is also inside ordinary matter, tries to connect ordinary matter into a single whole. Perhaps the movement of ordinary matter by dark matter rotates the inner substructures of the rings.
That's interesting.
Allows inertial energy to be stored. Dark matter may consist of the tiniest fractal substructures that repel each other, causing the expansion of the universe. So there's a reference 4 has been highlighted, golden ratio, ionic and atom nuclei bond length, molecular physics, 2005, and these two here by Osmera.
Three, there's three.
18, 19, and 20.
Yeah. And
okay,
then there's
there's
4 more
here by Osmera. Okay.
Yeah. So very, very interesting. It's his whole theory. I know that I stopped you guys from talking about certain things at certain points, but we had to get through all of it to sort of understand his whole grand theory, which is amazing. I've read through this paper several times now, and we'll make sure that you guys all have this paper as well too. So we're still recording. Does anybody have any comments or questions before we stop the recording? Then we can get into more conversation.
The conclusion helped answer some of my questions. The primary question at the very beginning, the structure of a single electron, had subcomponent pieces that were oppositely charged.
Mm-hmm.
And that was clear. It wasn't clear. Okay, then what when you sum up these pieces, what gives the net charge of the electron? What gives the net charge of the positron? I didn't say, oh, there's one extra piece, although it sounded like I have an even number of pieces. So you made that clear as an even number. So therefore, if I want a net charge, the question would arrive, oh, do I have 2 extra of these? Or what is the charge of a subpiece? He didn't say what that was. But clearly, when I got done assembling, I end up with the charge of the electron, right? We have to hit our goal, but it wasn't clear the nature of these subpieces, other than he gave a quantity, how many there are for an electron and positron. So there's kind of like this fundamental kind of disconnect. The other idea, the fact that both of these subpieces participate is a common pattern that we see throughout on the various scales and even the Feynman diagrams. Something neutral like a photon has the 2 subpieces, electron positron pairs, that come in and out of existence as it propagates, etc. And so we created in the model, kind of like when you say fractal, I imagine, keeps going down and scale. You can assembling as you want to assemble from subpieces. That kind of makes sense. So it wasn't clear what the individual subpiece is. It was clear the number of them, and it was clear they had opposite charges to help hold it together. So there's there's unknown questions on the fundamental, let's say, postulates of what is exactly going on. So I would pose that as still an open question to clarify the model. And then once he has his model, he's off and running. And then the other question was the size. All of a sudden, this one electron ring type structure expands out to the Bohr radius. I kind of personally like that idea, but it wasn't clear because in the math we have R sub E, but which of these two radii are we talking about? That wasn't clear. And perhaps there's even a relationship between the Bohr radius and the radius they want to assume for the individual electron. It's kind of implying there's some type of relationship, which would be cool if it were derived that way. Anyway, they're my comments. It's essentially they're in the form of questions because I don't know the answers to what I'm asking. I'm just asking to see if I can clarify the model.
Yeah.
So additional question to add to what Moray said. The discussion on the charge segments is a little confusing. We just read in the conclusion or the summary that an electron field has positron elements in it. And positron field has electron elements in it. That doesn't sit well with me personally. It would maybe mathematically convenient. I hope that is not the case, Pavel. And you've been very clear in stating you want to be able to mathematically describe this, but I cannot conceive of electrons and positrons living happily together in charge segments that are that heterogeneous. So we'll leave that as an open question also.
Cool. Okay. Well, let's stop the recording and maybe we can get into a little bit more discussion. Thanks for Pavel and Moray for being here today with the group. It's amazing. And maybe, Moray, we can get more clarification from Pavel in the future on some of the questions that you asked, both you and Chip as well. Yeah.
Okay, this is just for the recording. I'm going to say thank you everyone for listening. I hope you have a wonderful rest of the week. Cheers. Bye.